Actually, lives in this community.
Just take a selfie with you. Go. You can take.
Lives in our community. Danielle Gelb is not related to Mark. Sorry about that. Mark is at a wedding in Lakewood, that's why he's not here today. We have to learn a little bit about genetic counseling, particularly in our community where it's very important, and we're going to hear about it right now.
Okay. All right. Hi, everybody. First of all, I hope everyone had a wonderful Hanukkah, and we're all recovering from our jelly donuts and latkes. I just want to thank you all. Thank Dr. Bright for hosting. Thank you all for coming. I really appreciate being here, especially as a member of this community. My name is Danielle. Singer is my maiden name. Gelb is my married name. You'll probably see both. And I'm the cancer genetic counselor over here at NYPQ. So today I'm just going to be getting basic understanding of genetics, talk a little more about cancer genetics, which cancers can be inherited, give you some examples, and then we'll go from there. Okay, so first of all, a lot of times people ask me, what is a genetic counselor? So we are trained individuals in human genetics and psychology and counseling. We work as a member of the healthcare team, providing information and support for people who either have genetic disease in their family or they're concerned about their risk for genetic disease in their family. So that can mean a lot of different things depending on what setting we're working in. So I happen to be a cancer genetic counselor. So I'm going to be talking obviously about the genetics of cancer, but some of you may be familiar, especially in our community, of other types of genetic counselors that work with other genetic issues. So first of all, who is at high risk of a hereditary cancer? So it's really only, as Dr. Villani said, a very small proportion of all cancer. Most cancers are not hereditary. 90% of the time it isn't hereditary. There are other factors, environmental factors, smoking, aging, hormones, diet, exercise, stress, all of those things, right? Only about 10% of the time is the cancer actually hereditary in the family. And really the key in identifying who is at risk and who has a hereditary cancer in their family is the family history. So when I meet with someone, the first thing I want to know is who in the family had cancer. That's going to give me a lot of information. It gives me an accurate risk assessment, it helps me guide the genetic counseling, and then what's the appropriate medical follow-up for that person. So a little bit of a misnomer. Actually, all cancer is genetic. All cancer starts in our genes. What happens is there's a genetic mutation, whether it's because of the environment or because of something we eat or it's something random or because of aging. And then the gene stops working. And because of the gene stops working, we have certain genes that control growth. And so if the gene stops working, then our cells grow and grow and grow, and that's essentially what cancer is. Okay? But not all cancer is hereditary. So when I say genetic and hereditary, there's two different things. Okay, so not all cancer is hereditary, only about 5 to 10% of the time, like I said. And what are the features of hereditary cancer? So when I'm, trying to identify who is at risk, or if all of you are trying to identify who at risk, the first thing we're looking for is age of diagnosis. So anytime we see a cancer that was diagnosed at a young age, and young really means like under 50, under 45, that's a little bit young. We're also looking for people who've had multiple primary cancers or bilateral cancer. So for example, if a woman has had 2 breast cancers, or if she's had breast cancer at a young age, that would be concerning. Another risk factor, of course, is multiple generations affected. So if I'm seeing multiple people who've all had the same kind of cancer in the family, then that's suspicious. We look for rare cancers. Believe it or not, men do get breast cancer. That's pretty rare, but it happens. And also ovarian cancer is a little more of a rare type of cancer. We look for unusual tumor markers, like you may have heard of triple negative breast cancer. And then, of course, down here is probably most important for us here, right, is Ashkenazi Jewish ancestry. So there are certain cancers that are more common in our population and puts us at a little bit of a higher risk. Okay, so again, when I'm meeting with someone, this is the information that I'm looking for, and it gives me more of a picture as to what could be going on in the family. So the first thing is, really it's all the relatives in the family, even the people who haven't had cancer. So I'm looking for their current age. For the ones who've had cancer, how old were they when they were diagnosed, and how old were they when they passed away? In other words, if someone was diagnosed with a breast cancer at 50, but they lived until the age of 80, that still gives me a lot of information, right? Whereas if somebody had a really severe, metastatic cancer at the age of 40 and passed away, that also gives me some information. We're looking for the type of cancer, the location, the stage, any information we can gather about the cancers in the family. And then if someone had a second cancer, was that a new cancer, or is that the first cancer that spread? That's also important. We look for environmental exposures like smoking, chemicals. If someone worked around a factory, that might give me some information. And then, of course, ethnicity, like I said. And then, information about all relatives. So we're looking about health status, history of illnesses, presence of other findings, and then if someone passed away, what caused their death? If it wasn't cancer, what was it? So a little bit about basic genetics. I'm just going to give you a quick overview without getting too scientific. Up here on the left is a picture of a cell. Inside of each of our cells, we have thousands and thousands of genes. So if you zoom in closer, you see a picture of what we call a chromosome. Each chromosome has all of our DNA on it, all of our genes. So the way that I like to think about it, this is the analogy that I use, all of our genes, it's sort of like a big book of information, right? It's sort of like a book of instructions. It tells our body how to function. We have genes for our eye color, we have genes that tell our heart how to function, we have genes that tell our kidneys how to function, but we also have genes that protect us against cancer. Okay, so it's a big book of information. Within the book, we have chapters. Those are the chromosomes. And then within each chapter, we have sentences. Those are the genes. So all a gene really is, it's like a sentence or a string of letters. Okay, and our body reads through the gene, like reading a sentence, and it gives instructions. But sometimes someone can be born with a problem in one of those genes. And that's what we call a mutation. So again, if you're thinking of a gene like a sentence, a mutation is kind of like a typo or a spelling error. So this example right here, it says the gray cat ran down the hall. Right below it, it says the gray cat ran down the ball. One letter got changed, but the whole sentence doesn't make any sense anymore. It's the same thing with these genes. So there are certain genes that we're born with, that we inherit from our parents, that are there to protect us against cancer. That's their job. But in some families, someone can be born with a mutation or a typo in the gene, and then the gene stops working. It can't protect us against cancer anymore. So I'll just skip through this pretty quickly. Basically, this is a picture of all of our genes. And this would be a woman because she has 2 X chromosomes. A man would have an X and a Y. And I'm just pointing that out to remind you that these are genes that both men and women have. So even when we're talking about breast cancer and other types of ovarian cancer, these are genes that get passed down from men and from women. So when I'm taking a family history, I'm going to ask about both sides of the family, not just the women in the family, women and men. These are genes that can get passed through men also. Okay. So just to give you some examples of some of the genes. So many of you may have heard of the BRCA genes. Raise your hand if you've heard of BRCA.
I've had it.
Yeah, so many of you in this room have heard of it. BRCA really stands for, it's BRCA, so there's 2 genes. One of them is called the BRCA1 gene, the other one is called BRCA2. And these are 2 genes that all of us have. I have them, you have them, men have them. They're there to protect us against breast and ovarian cancer, and in men, prostate cancer. But like I said, sometimes in a family there can be a problem in the gene, so the gene isn't working. Therefore, those people have a very high risk of getting certain types of cancer. So for example, women would have up to an 80% chance of getting breast cancer. That's pretty high. In the general population, it's really only about 10 to 12%. And then there are other types of cancers that can be raised, like ovarian cancer risk. So why is this, a question I get a lot is, why is this specifically relevant to our population, to the Ashkenazi Jewish population? And the reason is because 1 in 40 Ashkenazi Jews carries a mutation in one of these genes. Okay? So it really doesn't even matter what the family history is. But if you see anybody in the Ashkenazi Jewish population who's had a breast cancer or an ovarian cancer, we get a little suspicious, even if they weren't diagnosed at such a young age. And so if you look at a diagram of the two genes, these are pretty big genes. They're long genes. And anytime you have a mutation or a problem in the gene, it could be anywhere in the gene. It could be in the middle, could be in the end. But there are three very specific mutations that are more common in our population. Two of them are right there on the ends of BRCA1, and one of them is right there in the middle of BRCA2. So when someone's Ashkenazi Jewish and they have a family history of breast or ovarian cancer, the first place I'm going to look is those two genes. Okay, there's also another syndrome called Lynch syndrome, which raises the risk for colon, endometrial, and other types of cancer. Right? So there are other cancer genes we have. It's not just BRCA1 or BRCA2. So there are other types of cancers that can also be hereditary. And so if you have a significant family history of these types of cancers, then we might be suspicious that this could be Lynch syndrome. So I think the thing to remember is the next question that you might ask is, well, what happens if you find out you're at a higher risk of these types of cancer? What do you do about that? Is there something you can do about it? And there are things we do. There are things we recommend. We recommend increased screening. These women might start doing mammograms in their 20s, at a very young age. So there are very specific medical recommendations that we can give to help prevent the cancer. And that's why knowing this information is helpful. It's scary, right? Knowing that you have a higher risk of getting cancer can be scary, but it's helpful. It's helpful because we can do something about it. And that's really why we do genetic testing, because it gives us information for you and for your family. And there are over 100 genes that we're testing for now. The field has exploded. Almost everyone here has heard of BRCA1 and BRCA2. But there are now, tens to hundreds of genes that we know that are associated with breast cancer. So a question I get a lot is, Danielle, I was tested 10 years ago for BRCA and I was negative. Does that mean, I need to be tested again? Well, maybe. If you have a strong family history, there could be another gene running in the family. And the field is constantly changing. So I always tell people, check back in because things do change. Okay, so how does the process work? So let's say, you have a family history and you're concerned. So the first step is to identify the people that are at risk. That can be done by yourselves, by your doctors. They say, you have a family history. That's a little suspicious, right? The next step would be to provide pre-test counseling. So before we go and rush and draw anyone's blood, we want to do an evaluation and make sure they're getting tested for the right thing. Make sure they really know what they're being tested for. The next thing, of course, is informed consent, right? We always want to know what are the risks and benefits of testing. How is this test really going to help me? We don't just want to draw someone's blood, right? We want to know what we're actually being tested for. We select and offer the right test, and then when the results come back, we give results. And then post-test counseling and follow-up. So what are we now going to do with these results? How do these results help myself and my family? So that's the process that we follow. Okay, so now I want to talk about some other things. I've given you a lot of information. But I think, in some ways it's very easy to think of genetic testing as just like any other medical test. It's just a blood test, right? How is that really different than any other test? You go to the doctor, you get the blood test, that's it, right? But in a lot of ways it's more than that, because you're getting information about your risk for cancer and your family's risk for cancer. And there are a lot of emotional issues that come along with that and psychological things to think about. So anxiety, fear, right? We were just talking about fear, but how would you feel if you found out you had an 80% risk of cancer? That's kind of scary. Guilt. What about the possibility of passing this down to a child? A lot of times, even though it's not our fault, what we inherit and what we pass down to our kids, and we all know that, right? But sometimes people feel guilty. What if we find out this is genetic and I could have passed this to my child? So that's something that comes up also. Altered self-esteem. Sometimes you might think of yourself differently, after having done a genetic test. Depression, grief, changes in family dynamics. Sometimes there's tension in families that comes up. And having a genetic test result can, shake things up. Also, different people think about risk differently. So While one person in a family might say 80% risk of cancer, it's not that high, I'm not that worried. Whereas someone else might say, wow, 80%? So different people think of these risks differently and make different decisions. No two people are really the same. And that's really part of the counseling process, is no two people are going to see the information the same way. And that's really part of what we integrate into our conversations with people. And of course, there's various factors that influence your risk perception. So, if you have a family experience, if you're very, very close to your mother and she had a very severe cancer, right, that's going to impact you. You had a personal experience with someone in your family who had cancer versus someone who maybe didn't have as much experience with it, right? Or your personality. Sometimes people are really anxious people, right? Or sometimes they're very calm and free-flowing people. So sometimes it just depends on your personality. Family relationships, like I said, sometimes things can be tense in families. Educational level, cultural level, religious level, these are all factors that play into how someone might view whether their risk is considered high or low. Family history. So also tracking family history can be really difficult. I mean, we all have, unfortunately in our community, we have many people who've passed away from the Holocaust, from World War II. Sometimes we don't have the information. We wish we knew, but we don't know. And we don't know who in the family had cancer. And so sometimes I'll have people come to me and say, you know what, I'm not even in touch with my mother. I don't even know her side of the family, so I don't know who had cancer and who didn't. So we do the best we can with whatever information we have, but this can be challenging, and it brings up a lot of feelings when people meet with us, because talking about family history can be tough sometimes. Also, there's this issue of the genetic taint. So this is, I can't tell you how often this has come up. It's sort of like a stigma, right? So when you do a genetic test, it sort of puts a label on you. Oh, now you're considered at higher risk. And sometimes people worry, like, how is this gonna affect the shit up for my child, right? Now she's at higher risk for cancer, so is she gonna find a match? And that happens too. What I always tell people is, if you know you're at a higher risk for cancer, you're almost the luckiest person, because you can actually prevent it. So now that person never has to worry about, getting cancer. That potential match never has to worry about his wife, unfortunately, dealing with cancer or dying from cancer, because there's things we can do to prevent it. But, we can't shake this in our community. It definitely comes up. Especially for single women, right? Single women have pressure to marry. In our community, it can affect dating. When do I tell someone I'm dating? How do I tell them that I'm at a higher risk for cancer, or that there's cancer in my family? Fertility, it can certainly affect when you have children. So that, it can really affect people. So I think my goal, obviously, is not to scare people. I think it's important to be aware of the utility of doing genetic testing. And really, genetic counseling, and I'm a genetic counselor, of course, but it's an integral part of this process. It's not just about doing a blood test. You want to make sure you're doing the right test and that you really understand the implications of these results for yourself and for your family. And we can, genetics professionals, and it's not just genetic counselors, it's also MD geneticists or anyone who's trained in genetics, can help interpret the family history. We can help deal with some of these complex psychological issues. We can help order the right test, interpret the right test, and then facilitate the proper medical management. So if we know someone's at a higher risk, we can help facilitate high-risk screening, whatever we need to do to help them prevent the cancer. Okay, so I know I just threw a lot of information your way, but in sum, cancer can be hereditary. Most of the time it isn't. If you have a family history, obviously you'd want to talk to your physician or to a genetic counselor. It accounts for about 5 to 10% of all cancers. It's really a complex process. It's so much more than just a blood test. It's so much more than just a blood test. You really want to make sure you're getting the right test, you're talking to the right person, and you have those results interpreted in the right way. So it really should always involve somebody who's trained in genetics. And then be aware of your family history. Share this information, communicate this information It could impact other people in your family. It helps save lives. It helps them prevent the cancer. So I always encourage people to talk to their family members. You know, in certain generations or certain cultures, it's not so common to talk about your health with your family. But you know, especially in our community, the Ashkenazi Jewish community, when we're at a higher risk, we need to make sure that we're communicating with our family members and we're sharing all of this information. So, any questions? I gave a lot of information. Yeah.
Yes, once we've identified these genes, can